Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now, we are going to learn about how to find the velocity in front of the shock wave. Consider the velocity and temperature behind a normal shock wave are 329 meter per second and 1500 Kelvin respectively. Calculate the velocity in front of the shock wave. Given data. Here, the velocity behind a normal shock wave U2 is 329 meter per second and the temperature behind a shock wave T2 is 1500 Kelvin. Now, the question is, what is the velocity ahead of the shock wave? In physics, a shock wave is a type of propagating disturbance that moves faster than the local speed of sound in the medium. Like an ordinary wave, a shock wave carries energy and can propagate through a medium, but is characterized by an abrupt, nearly discontinuous change in pressure, temperature, and density of the medium. If the shock wave is perpendicular to the flow direction, it is called a normal shock wave. First, using the given data, find the Mach number behind a normal shock wave. As we know, Mach number is the ratio of speed of body to the speed of sound in the surrounding medium. Thus, we can write m is equal to u divided by a, where u is the local flow velocity with respect to the boundaries and a is the speed of sound in the medium. The expression of speed of sound a is equal to square root of gamma into r into t, where gamma is the heat capacity ratio, which is 1.4, and r is the gas constant of air, which is 287 joules per kilogram, and T1 is the temperature behind the shock wave. Substitute these values and we get A1 is equal to 776.3 meter per second. By dividing the values of velocity and speed of sound, we get the Mach number behind the normal shock is 0.4238. To find the velocity ahead of the shock wave, we must know speed of sound and Mach number in front of shock wave. From normal shock properties, we see there is no precise entry for M2 0.4238. Rather, this number lies between 0.4236 at M1 4.5 and 0.4245 at M1 4.45. By interpolation, we get M1 is equal to 4.4898. And again, from normal shock properties, we note that at Mach number 0.4236, temperature ratio T2 by T1 is 4.875, and at Mach number 0.4245, the temperature ratio is 4.788. Interpolating to find the temperature ratio at Mach number 0.4238, we find the temperature ratio T2 by T1 is 4.856. Now, we can find the temperature ahead of the shock wave. We can write T1 is equal to T2 divided by temperature ratio T2 by T1. Substitute the values of T2 and temperature ratio T2 by T1 and simplify. We get T1 is equal to 308.9 Kelvin. Now find speed of sound ahead the shock wave. Substitute the values of gamma and r and T1 values in this equation and solve. We get A1 is 352.3 meter per second. Now we can find out the required velocity by multiplying Mach number M1 and speed of sound A1. Thus, the required velocity ahead of the shock wave is 158 meter per second. Single velocity does not specify a normal shock wave. However, velocity in combination with temperature specifies the normal shock, where U1 and T1 ahead of the shock specified the shock. We see that U2 and T2 behind the shock also are sufficient to specify the shock. Did you know? The large wings of the airplane are useless unless you use the flaps on the tail horizontal stabilizers first. Only when you manage to lift the nose and direct air circulation to the lower part of the plane, the large wings begin to create enough thrust to lift the airplane into the air. In the event of an accident, the first thing that automatically turns off in an airplane is power. The reason for it is the danger of fire. That's why the lights always go off when landing and taking off at night. Passengers' eyes need to get used to the dark in case of unforeseen circumstances. If someone tells you after a long flight that you lost some weight, he is not lying to you. 3 hours of flying can drain 1.5 liters of water from a human body, provided you have not been drinking anything. Of course, you will not lose 15 kilos if you fly for 30 hours.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.